Friends, in this video we will evaluate double integral. We see some examples and how we can obtain or evaluate the double integrals. We will discuss about that in this video. Suppose I have to integrate double integration of x square plus y square between the limit 0 to n, 0 to b. This shows that this y, we have to evaluate this with respect to y first and then with respect to x, so that this will be integration 0 to a. X square is constant, integration of this constant is y plus y square is y cube divided by 3 between the limit 0 to a into dx. Let us put the 0 to b. Let us put the value upper integral, integration 0 to a x square b plus 1 by 3 b cube, and at lower limit y equal to 0, this will be 0 into dx. Now we have to evaluate with respect to x. B is constant, b into x cube divided by 3 plus 1 by 3 b cube into x between the limit 0 to a equal to b into a cube divided by 3 plus 1 by 3 a into b cube. Here we can take a and b common, a b common, here we get a square plus b square. So this is an answer of this problem. Let us consider one more problem to evaluate of double integration. Suppose we would like to evaluate integration 0 to a, integration 0 to under root of a square minus y square into under root of a square minus x square minus y square dy into dx. We have to evaluate this with respect to x. Therefore, we write this as integration 0 to a, integration 0 to under root a square minus y square under root of a square minus y square minus x square into dy into dx. Friend, a square and y square are constant when we integrate this with respect to x. We have a standard formula, integration of under root of x square minus a square minus x square equal to 1 by 2 under root of a square minus x square plus 1 by 2 a square into sine inverse of x divided by a. This is the standard formula. Let us apply that. Integration 0 to a into 1 divided by 2 into x into here x into under root of a square minus y square minus x square plus 1 by 2 into a square, that is a square minus y square into sine inverse of x divided by a square minus y square under root of a square minus y square. Okay, so this is between the limit 0 to under root of a square minus y square and dy. Let us put this value upper limit and lower limit equal to integration 0 to a into 1 divided by 2 into upper limit a square minus y square into under root of a square minus y square minus a square minus y square plus 1 by 2 a square minus y square sine inverse of under root of a square minus y square divided by under root of a square minus y square into dy. Here you can see that x square minus y square, this will be 0. So this is integration 0 to a 1 by 2 a square minus y square into sine inverse of 1. Sine inverse of 1 is pi by 2 into dy. Pi by 2 and this 1 by 2 is common. constant, this will be pi by 4, integration 0 to a square minus y square into dy equal to pi divided by 4 into a square y minus a cube divided by 3 between the limit 0 to a, pi divided by 4 into, substituting the upper limit a cube minus a cube divided by 3, at lower limit it is 0. So this is equal to pi divided by 4 into 3a cube means 2a cube divided by 3. So 2 2s are 4 equal to pi a cube divided by 6. So this is the answer of this problem. Now let us take one more example. Evaluate double integration x square plus y square dx dy over the region in the positive quadrant for which x plus y less than equal to 1. Here this is, we have to evaluate this in the first quadrant, and if we consider this as x plus y is equal to 1, then the lower limit x equal to 0, y equal to 0. On x axis y equal to 0, so we get x is equal to 1, and the line gives us y equal to 1 minus x. Therefore the bounds of this integration are x equal to 0, x equal to 1, y equal to 0 and y equal to 1 minus x. Therefore double integral over the region a x square plus y square dx into dy equal to integration 0 to 1 minus x square plus y square into dx into dy. So integrate this with respect to y first. Integration 0 to 1 x square y plus y cube divided by 3 between the limit 0 to 1 minus x equal to integration 0 to 1 x square into 1 minus x plus 1 minus x whole cube divided by 3 between the limit into dx. Okay, lower limit is a 0, at 0 we get 0. So when we integrate this x into 1, x square into 1, x square, so x cube divided by 3 minus x into x square, x cube, its integration of x cube x raised to 4 divided by 4 plus this 1 by 3, and 1 minus x whole cube means 1 minus x whole raised to 4 divided by minus 4, this, and between the limit 0 to 1 equal to, substituting the upper limit 1 by 3 minus 1 by 4 minus, at 1 minus 1 will be 0, at lower limit this is an upper limit, at lower limit this is 0, and this is minus become plus x equal to 0, so 1 divided by 12 equal to, here 1 divided by 3 minus 1 by 4 plus 1 divided by 12, this is the, then take the LCM, 12 3 4s are 12 minus 3 plus 1 equal to 4 minus 3 1 plus 1 2 divided by 12 1 divided by 6. So this is an answer of this integration.